Okay, so what we're going to do is, we kind of touched on it yesterday a little bit, and I'm going to put a little x and y axis right here. I'm not going to do the unit circle, I don't think. I don't know. We'll see how it goes, okay? We'll see how I start feeling, depending on what I want to do here. Let's talk about this thing first. We kind of mentioned it a little bit yesterday when we just briefly mentioned the unit circle. Remember we said if this was 0 degrees, what is this right here? It's 90 degrees. So what we have is this. Let me draw this in a different color. Let's make it red. This is not anything, the radius isn't 1 or anything like that, okay? It's just a line coming out like this. Okay, this is, they don't call it this in this lesson, but this is a vector. Basically, it starts here and it goes in that direction. Remember we did vectors in, it was chapter 8, I think, yep. So it starts here, it goes this direction. If I wanted to find the angle of that thing right there, where do I measure it from? Do I measure it from the top down like this? Do I measure it from the bottom all the way to here? No. I start from the 0 degrees, right? This is 0 degrees. I start at 0, which is the x-axis, right? I call it the positive x-axis. So I start over here, and then I go counterclockwise. You see that? Let's do that in a different color. We kind of did. We kind of discussed this a little bit already. So who knows? If it looks like we've already done a lot of this stuff earlier in the year, maybe we will start talking about unit circle, but let's see. So I go counterclockwise. So whatever that angle is right there, that's the angle of that line, of that vector. Okay? So let's say it's, 40 degrees. Right? That would be 40 degrees right there. But there's another way to label this angle. You could go in the opposite direction. Let's do that in a different color. Let's go blue. You could go in the opposite direction, which is clockwise. But if I start here, you always start here. They call this, they give it a name. They call it the initial side. They call this thing right here the initial side. Initial means that's where you start, right? Initially you begin here. You've heard that word before, right? So you start here. This thing right here would be your initial side, right? If I made a triangle out of it, that side would be the initial side. Where we end up would be the terminal side. So this red one, this is where we end. See, we start here, right, at the initial side, and we end up right here. We call that the terminal side. I probably won't refer to it all that often in that way, but if you read the book or if you look somewhere, they'll talk about that. So we start here, we end here. What's another way I could get to that red line? I could start here and go counterclockwise, or I could start here and go what? Clockwise. And that would take us, oops, slipped a little bit. There we go. All the way to here. Look at that blue one right there. I could use that angle if I wanted to, but I'm going in the opposite direction. How many degrees would that be? What is it? 360 minus 40, exactly. So that blue one right there would be 320. So I'm going to put 320. But it's not just 320. I went in the opposite direction that I would normally go. Okay, our convention, our regular way of doing things is going counterclockwise. That's kind of normal. This is a little bit abnormal, okay, to go in this direction. So I'm not just going to call it 320. I'm going to call it negative 320. Okay, it doesn't mean it's... So it's just going in the opposite direction. So this negative right here just means I'm going the other way. That's all it's saying. You follow me on that? So, because what would positive 320 be? Right, watch this. If I did, what's another color I can use? Let's use this light green right here. Watch, what would positive 320? If I started here, then I would go where? To 90, to 180, to 270, and how much more? To 320. 50 degrees more. So, oops, a little scraggly looking. And then, so look, that is different, isn't it? That's a different vector than the red one. So positive 320 and negative 320, you're at two completely different places. You with me on that? But negative 320 and what are at the same place? Positive 40. Do you see it? And what's true about 320 and 40, they add up to 360, don't they? Right? If I forget the negative, right? The 320 and the 40. So we say that I think the word they use is coterminal. Yeah, I think it's, let me trying to find out where the word is. They have it somewhere in here. Oh, there it is. Coterminal angles. So 40 degrees and negative 320 degrees, you really end up at the same exact spot. You see that? So if I just said, go 40 degrees, well, you would start here, go counterclockwise 40 degrees. Boom, you're right here where that red line is. Or I could say, well, go negative 320 degrees. What does that mean? Start at the same spot, but what do? You go in the other direction. But you got to go 320 degrees in the other direction. But where do you end up? At the exact same spot. So these two right here give you the same exact line. You follow me? It takes you to the same line. You go in different directions. One's a little shortcut. One's right, a little longer way to get there. But you end up at the same spot. We call these coterminal angles. Coterminal. Again, I probably won't refer to these as that very often, but it's in the book and it's highlighted and it's bold and all that kind of stuff. I don't know, just because we don't really talk about them. I guess you could. Yeah, well, I guess we will refer to it every once in a while. So what do you think? That's not so bad, is it? You okay with that? So you just go, the normal, quote, the normal direction is counterclockwise. It's going up from the positive x-axis, okay? So that's the normal direction. The other direction would be clockwise, all right, 320, and that gets you to the same exact spot. Make sense? Here's another thing that you could do. Let me do this. Let me just copy this. Put it right here. Let's put that same 40 degree. Oops. There we go. Let's put the same 40 degree vector right there. So that would be 40 degrees. Let's do it in yellow again. Try to stay coordinated here with our colors. So, and that's 40 degrees right there. Watch this. You could also get to the same spot by starting here. What did we use before? Blue. We could start here, and we could, oh, come on. There he goes. We could go all the way around. How far have I gone right now? And then I could end up back here like this. You see that? So this right here would be what? 400 degrees. Okay? So 40 degrees and 400 degrees are exactly the same spot. You end up at the same spot. This one, we just took the scenic route, right? We went around the block once before we got there, but we still went counterclockwise because it's still positive, right? It's still positive, so we still went counterclockwise, but we went one full time around the circle plus that much more. So 40 degrees and 400 degrees also put you at the same spot, don't they? Make sense? How many times could I go around the circle and still end up at 40? A lot? Okay, a lot. You could keep going. For how long? Forever and ever. So how many is that? Right, an infinite number of times. You can go an infinite number of times around the circle. You can keep going around. If you end up here, still you're at the same spot, right? Make sense? So 400 degrees and 40 degrees gives you the same exact angle. So they are also coterminal, aren't they? So how would you find a coterminal angle? You could, watch, you started at 40. How do we find that negative 320? What do we do? Right, but let's mathematically, what would we do as far as addition, subtraction? Minus, no, it'd be 40 minus 360. Okay, because we went the opposite direction, right? So that gives you the negative 320. You with me on that? So you could start at the angle where you wanted to end up, right? You could take 360 away, or you could do what? You could add 360, okay, and that'll give you 400. Look, all these places, 40 degrees, negative 320, positive 400, all end up at the same exact place. You got it? So they're all coterminal. Because terminal means that's where you end. The co is kind of like with, right? So they all end up in the same place. So I don't know how you throw the width in there, but that's what that's kind of what it means. All right, enough of that. Let's talk radians now. I bet you're excited about that, aren't you? Yeah, I could, but not so much. What I'm going to do, I am going to draw a circle here. And this is where I'm so tempted to talk about a unit circle. And I just might. You know what? I'm going to. This is as good a place as any to start talking about the unit circle. Well, actually, before we start talking about the unit circle, I'm trying to figure out which direction I want to go. I got all these ways I want to go. It's going to help you. Remember you said the girl in that other class had this big long sheet. She had to memorize it, or she could use the chart or whatever. Okay? The unit circle is going to really, really help you not have to necessarily memorize everything. It'll help you visualize it, and then you can always figure it out. To me, that's better. People learn different ways. A lot of people have great memories, and they would rather memorize a whole list of stuff, and that's their thing. For me, that's not my thing. I like to visualize it. I like to know what's really going on, okay, instead of memorizing a whole bunch of stuff, because that just never worked for me very well. What were you going to do otherwise? I'll show you. Just hang on, okay? Enjoy the ride, and we'll get there eventually, all right? So let's do this. Let's talk about what a radian is, all right? Let's write that word down, radian. Here's a circle, and the reason I put a circle here is, watch this. If I put that little yellow line right there, what is that to the circle, that yellow line? That's a radius, isn't it? Would you agree? Okay. Now, I probably won't be able to do this real super accurate, but it'll be pretty close. What I want to do is this. Remember we did back in geometry, we found like the distance like around the whole circle, circumference, and then we found the distance around like 30 degrees. You know, remember that? The length of the arc. Remember we did that? The length of the arc at 30 degrees, at 50 degrees, whatever it was. Okay, so for instance, if this was 30 degrees, what would the length of this arc right here be? And let's say the radius is, let's just put a number in here. Let's say it's 5. Okay, right. So it would be 30 over 360, and then it would be what? Not squared. We're finding the distance around this. We're not finding the area. We're not finding the area of this little chunk. We're just trying to. So it's 2 pi r, right? Because 2 pi r is the distance around a whole entire circle. Would you agree? So it's 2 pi r. In this case, it's what? 5. Throw it in the calculator, and you got that distance. You with me so far on this? Okay. What a radian is this. It's the, actually I shouldn't even say, let me think how I want to explain this. It's not necessarily the distance around, it's the, no it is. Here's what I want to do. See how that 30 degrees, that arc looks quite a bit shorter than what that length of that radius is, isn't it? What a radian is this. If I took this radius, now, it's hard for me to do it, and I don't think I'll really be able to do it, but if I took this length, whatever that length is, and if I stretched it, right, I took that radius, and it was bendy, okay? It was like a piece of string. Everybody watching? Everybody looking up here? Come on. So if I took a piece of string, and I measured the length of the radius, okay, from here to here, and I took that string, and I wrapped it around the circle, it makes a certain arc, doesn't it? Yeah. That arc is considered to be 1 radian. That's what a radian is. Okay? I'll say it again. It was a little bit, so we'll say it a few times. Let's get rid of that yellow. Okay. I'm going to get rid of the 30, get rid of this. Okay, let's start again. So if I took this radius, and the radius would be from here to here, agree? And if I measured it, let's make it a little thicker so I can see it. Okay? If I took that, and I measured the length of it, and let's say it was a piece of string, so it can wrap around the circle. Okay, so I took this string and I started wrapping it around the circle. Let's just kind of estimate, because this is all I can do right here with this program. All I can do is estimate. If I had GeoGebra, I could probably do it, but it would take me too long to learn how to use it. But let's just estimate. I'd say Oh, I need to do a, watch. There we go. So tell me when you think the length of this arc is about around in there somewhere? Maybe a little less? So if I took this and stretched, I think, because I got to stretch it out. See how it's curved right here? If I took that thing and I stretched it out, it needs to be the same length as this right here. You see what I'm trying to do? All right. Whether or not we think it's we think it's accurate, it's fine. Okay, I'm not worrying about the accuracy so much. Watch this. If I connected another radius to this, let's make this a little thicker. There we go. Do you see the arc that's formed? Yeah. It's an angle, isn't it? An arc. Well, I shouldn't say an arc's an angle. It's measured in degrees, correct? The degree, it's not the degree, but the measure of that arc is 1 radian. It's not how long it is, it's the... You remember how we did this? This is theta, right? Yeah. This arc measure, the measure of the arc, not the length of the arc, okay? The measure, are we listening? Yeah. She's not. Up here. The measure of the arc, not the length of the arc, the measure of the arc is going to be the same as the measure of this angle right here. Okay, and the measure of that arc is called 1 radian. That angle right here is also called a radian. So we can actually measure angles 2 different ways. We're used to degrees, right? Everything we've ever done so far, we've always measured angles in degrees. Your little compass thing measures it in degrees. You always say 90 degrees. You always say 180 degrees. Agree with that? Now it's a little different. Now we're measuring things in things called radians. And what is a radian? The radian is the measure, the measure of the arc that's formed by the length of the radius. Hear what I just said? So if I take the length of that radius and I stretch it around the circle, the measure of the arc that's formed, from that is considered to be 1 radian. So this angle is 1 radian. Let's do some more. Can you put numbers in there? Make a radian? I got a number. It's 1 radian. And I'll show you. No, I know what I'm going to do this way. Okay? I know what you're thinking, but I have to do it this way because this is the way that makes sense. Let's do another radian. So if I take that same distance, I don't know if I could copy and paste it. I'd have to rotate it though, wouldn't I? I don't know if that's any better. Oh, that's not too bad. That's pretty close. Now again, I'm not super accurate on this, right? But let's say that's another radian. So from here to here, that's another radian. Okay? It's the same. Should make that thicker so I can read it. There we go. So that's 1 radian. That's 1 radian. Yeah, because remember, the angle is the same thing as the arc. Remember, central angle is equal to the arc that it makes. So this is 1 radian. Remember, there are 2 different ways to measure angles. One is degrees, one is radians. So this is considered 1 radian. The arc is 1 radian, the angle is 1 radian. So from here to here would be how many radians altogether? 2. So that's 1 radian, that's 2 radians. Let's do it one more time. We'll answer your questions in a second. I got to work this thing out. What do you think? It's pretty close, isn't it? See what I did? I just copied and pasted. Now, it looks like we should have gone a little bit longer on this, but that's okay. This is now another radian. Well, let's do a line from here to there. Yeah, that works out pretty well for what I'm trying to do. So what's this angle inside of here then? That's theta, and that's 1 radian. Would you agree? So that's 1 radian. That one right there is 1 radian. And then this one right here is 1 radian. Now here's where it gets interesting. Do you think that's 1 full radian? No. So from here to here would be how many radians? It'd be 3 radians. This little bit right here is just a little bit more than 3. What number, when you're talking about circles, is just a little bit more than 3? Pi is, isn't it? So what do you think this measure is right here? Well, this is 3. What's pi? 0.14, right. So this right here is what? 0.14 radians. I'll just put RAD for radians. So look, that's 1 radian, that's 2 radians, that's 3 radians, and just a little bit more is how much? 0.14 radians. So altogether, now this is where it's fun. Watch this. Altogether, you don't agree? From here all the way to here. It's 180 degrees, right? But what is it in radians? It's not 3 pi, it's what? That's 1, 2, 3.14, so it's pi radians. So that angle, this arc, or this angle from here to here, it's 180 degrees, but it's also what in radians? It's pi radians. So halfway around a circle is pi radians. What is it if we went all the way around the circle? It would be 2 pi radians. Exactly. Does that make sense? So once halfway around the circle is actually pi radians. And why? Because there's 1, 2, 3, and just a little bit, which is the 0.14, and that's pi. It's pi radians. Now, what did we say? We said 180 degrees. Remember, there's 2 ways to measure angles. One is by degrees and one is by radians. So 180 degrees is equal to what? To pi. Now, we don't normally write, see how I wrote radians all the time here? It really doesn't have a measurement. It doesn't have a unit. You don't really write radians. We just say 180 degrees equals pi. So watch this real quick. Let me show you one thing real quick. Let's go to 90 degrees. Okay? How many radians would it be at 90 degrees? It wouldn't be 2, because 2 comes out here like this. Remember, from here to here is pi, so this is... Don't give me decimals. Don't give me decimals. In terms of pi, from here to here would be 1 pi. From here to here would be half a pi, or what? Pi over 2. You follow me? How'd you get pi over 2? Watch this real quick. 90 degrees, I'm going to put it over 1. Remember doing unit multipliers? If I have 9 degrees up top, I'm going to have degrees on the bottom. Do you agree we can do this? Why can we do that? Because it's equal to... It's the same thing. Remember, the same thing on the top and the bottom is a 1. So watch what happens. That goes once, that goes what? Twice, and it's pi over 2. So I can take any angle and convert it into radians. I can do it the other way too. I can give any radians and convert it into degrees. And that's the kind of stuff you'll be doing on the worksheet. Okay? Tell you what, we'll just work on the worksheet tomorrow, okay? I'm not going to give it to you today because we didn't quite get far enough. So if they give you something in degrees, like if they gave you like 45 degrees, how would you change that into radians? You put it over 1, and then you'd put 180 down here so that the degrees cancel out. You put pi here, right? That goes once. That goes actually 4 times, so it's pi over 4. Okay?